All right, so we're going to do some basic solving of logarithms at this point. So we finished talking about properties, and now we're going to be looking at how do we solve. So for today's lesson, we are going to look at how to solve when we have the same base. Now the key is if you can have the same base, then your exponents are also equal. So for this example, if I have a raised to x and a raised to y, because these both have a base of a, that means that their exponents are equal to each other. So I'm going to have my calculator pulled up. I think while you're doing this, if you want to practice with me, you should have yours too. So the first thing I'm going to do to solve my logarithm is I'm going to convert it over. So if you like the loggy froggy, by all means, draw it out. So this is going to be 4 raised to x equals 256. So right now, I do not have the same base. I have a base of 4, and I have a base of 256. But can I turn 256 into a same base? So the question is if I take 4, I raise it to 2, that gives me 16. That won't work. 4 raised to 4 is 64. 4 raised to 3 was 64. And then we have 4 raised to 4. So I now know I can replace this 256, and I know that 256 is the same thing as 4 raised to 4. So since I now have the same base, I can say that my exponents are equal. So x equals 4. And I can also determine that. I can plug it right into my calculator. So I need to make sure I have a logarithm with a any base. So I'm going to type 4 in, and I can see that that does equal 4. All right, so same concept here. I'm going to convert this over so my base is the same, and then I'm going to raise it to x and equals 100. So I have 10 raised to x equals 100. So the question is what can I change 100 to so that it's 10 raised to something? Well, I have 10 raised to 2. That works out. So we're going to be changing this value here. So this is going to be 10 raised to x, 10 raised to 2. So I now have the same base. So therefore, x equals 2. All right. So then we're going to look at this one. This one's a little bit different. So if I have 2 raised to x and I have 228. Actually, this one is not different. It's the next one that is. Sorry about that. So I'm going to ask myself 2 raised to what? So 2 raised to 2. That's not 2 raised to 3 is 8. 2 raised to 4 is 16. 2 raised to 5 is 32. So we're getting closer. And then we have 2 raised to 7. So 2 raised to x equals 2 raised to 7. And I can see that I now have the same base. So x equals 7. Now, the next one is the one that I was talking about is a little bit different. And I'm going to be looking at this one. I'm still going to convert it over, but we're looking for the positive solution. So I'm going to convert this into an exponential. And I'm going to say that x raised to negative 1/2 equals 1 over 10. So I still want to get a common base here. Or I could try to get a common base here, but it's going to be virtually impossible to get a common base because of the fact that I have a base that is x. I have an unknown variable. So what I'm going to do is I'm going to look at my exponent, and I'm going to figure out how can I get rid of that exponent with my x. So I have negative 1/2. Now remember, when I have a power to a power, that means that we are going to multiply. So I can raise this entire piece to negative 2, because I know that negative 2 times negative 1/2 equals 1. You're trying to figure out what can you raise your power to in order to equal 1. But if I do it to one side, I have to do it to the other. So I have negative 1/2 and times negative 2. So those are going to cancel each other because they're going to equal 1. So because x equals 1 there, and then I have 1/10 raised to negative 2, and that's going to give me 100. Now, how can I do this without a calculator? Well, you kind of have to think about your exponent rules. So I have negative 2 as my exponent. So I can apply that negative 2 to both pieces. And once I apply that to both pieces, I have to remember that in order to get rid of a negative exponent, we flip it over the division sign. So this is going to be 10 raised to a positive 2, 1 raised to a positive 2, which is going to be 100 over 1, or 100. All right, so let's look at one more example here. So we're going to convert this over. So I have x raised to negative 2, and then I have equals to 1 over 49. So x raised to negative 2, 1 over 49. So this time I need to figure out what to raise my power to in order to get rid of negative 2. So we're going to multiply it by that reciprocal value. So we're going to raise it to negative 1/2. So these are going to cancel, because that's going to wind up equaling 1. So x equals, and then I have 1 over 49 raised to, and then I have negative 1/2. Let me put that negative in there. And we get our answer is 7. Alright, so I hope this helps. These are just some basic solving. We will get into more complicated versions